Okay, number 32, the A part, we just want to find the inverse function. We have a little method for doing that. The first thing, we have these three rules. Now remember, in order to find the inverse, the function must be 1 to 1. Well, this is a line, so it's no problem. It passes the horizontal line test, which means it's 1 to 1. Obviously, it passes the vertical line test, which means it's a function, so that's no issue. So basically what we do is the first thing we do, the first step is we write this as y. We change the f of x to y. The second step, remember, you just interchange the x and the y. So x equals 2y plus 3, then you solve for the y. So that's easy. I would just subtract 3 from both sides, divide by 2. And this is y. And the fourth step is instead of writing it as y, we call it f inverse of x. So that's all you have to do. So that's pretty easy. And those are the 4 steps in order to write an inverse function. Okay, the b part, a little more complicated here. We have this function. Now, first of all, we want to make sure that it's 1 to 1, so I did graph it to double check this. Now, if we look at this, this is a rational expression. If we look at the bottom can't be 0, so we know that if x is 1/5, 5 times 1/5 is 1, 1 minus 1 is 0, so we have a vertical asymptote at x equals 1/5. And then remember, these two highest degree powers are the same, so I have a horizontal asymptote. That's the ratio of the coefficients, 1 over 5. That's the coefficient of the highest degree term. So I kind of sketched it over here to make sure that it was 1 to 1. So this is what it looked like, and I tried some points. I tried to put 1 in here, and I got 3/4, and I put -1 in, I got -1/6. So it kind of looks like this. So you can see that it is a 1 to 1 function. Even though it's got some asymptotes and vertical and horizontal asymptotes, it's still 1 to 1, so we can still find the inverse. It has to be a 1 to 1 function. That means any horizontal line will only cross the function in one place. So yeah, it's 1 to 1. So you can check that out. Again, you know how to graph these rational functions. You should learn how to do that. And I just used a few checkpoints to figure out whether it was in these quadrants or these quadrants. Okay. So once we do that, then we follow the same procedure. First of all, we call the f of x y, and then we interchange the x and the y. That's our second step. And then I solve for y. So I have to multiply both sides by 5x minus 1. And then I can just multiply this out. So I get 5xy minus x equals y plus 2. Then I'll get all my y terms on the left and everything else on the right. So I subtract y and I add x. And then I can factor out the y because that's what I want to solve for. And then I can divide both sides by 5x minus 1, and I've got my y isolated. So y equals x plus 2 over 5x minus 1, and then instead of writing it as y, I write this as f inverse of x. And this is a function that happens to be its own inverse. That's kind of interesting. So this function is its own inverse. Okay? So I hope that makes sense. The same basic 4 steps. Okay. And now the third part C. This is a little trickier, so I kind of wanted to sketch this thing out because remember it has to be 1 to 1 and we have a parabola. So let's set this up here. And I try to work these out ahead of time because if I work them out, it takes a little more time and I've got to download these things. So this was my function over here, f of x. This is 32c. And first of all, it's a restricted domain. So that's going to make sense because it's a parabola, and a parabola is not 1 to 1. So I have to restrict the domain in order to make it 1 to 1. So this is our restricted domain. So let's take a look and see what it looks like. So basically, I just set it equal to y so I could graph it. So I want to find, in order to graph these things, we try to find the zeros, the intercepts, the vertex. So we can do all that. That's not too bad. It's a good review of our Algebra 2 techniques. So in order to find the zeros, I have to solve it. I'm not going to use the quadratic formula because it's really set up to complete the square. So this is you can either use the quadratic formula or complete the square. Lots of times people don't do complete the square when it works really better than the formula. So what I did was this is 1 and this is even number. It's real easy to complete the square. I just put my 1 on the other side, and then half of 2 is 1, so I add 1 to both sides. And this is a perfect square trinomial, so this is the factor form, x plus 1 squared, and 1 plus 1 is 2. Then I take the square root of both sides. So x plus 1 equals plus or minus the square root of 2. Then I subtract 1, so those are my roots. Now remember the square root of 2 is about 1.4. It's 1.414, but just a graph, we can use 1.4. So these would be my zeros, -1 plus 1.4, which should be just 0.4, and -1 minus 1.4 would be -2.4. So those are my two zeros. Now remember the vertex, it's a little sloppy here, but this is, remember, it was -b over 2a gave me the x value, then I put that back in the function to find the y value. Well, if I go back up here, -2 all over 2 times 1, which is 2, is -1. And if I put -1 back in here, -1 squared is 1, minus 1 is 0, and then 2 times -1 is -2. So there's my vertex. And then when x is 0, I can find the y-intercept. When x is 0, y is -1. And remember our domain, remember we were given a restricted domain, x is greater than 0. So let's kind of sketch this out and see what it looks like. And here we have it. And it's not a bad thing for you to do this, and you'll see, why in a moment. Okay, so these are my intercepts. This is a -2.4, and this is my 0.4. And my y-intercept was when x is 0, y is -1, so there's my intercept. And my vertex was -1, -2. So this is what the parabola looks like, except the domain is restricted so that x is greater than 0. So when we restrict the domain, you can see that it is 1-to-1. So we're in good shape there. Now, remember this. This is the domain. X is greater than 0. What's the range? Well, if x is greater than 0, y is going to be greater than -1. So you can see that. So you want to notate that. So for f of x, the domain is x is greater than 0. The range is y is greater than -1. Now when we take the inverse function, this is something that we talk about, but sometimes we forget this. For the inverse function, the domain and the ranges are flipped. They're exactly the opposite. So you want to notate this because when you're looking for your answer, this may enter into some decisions you have to make about the correct answer. So for f inverse of x, FOR, sorry about that, FOR, pardon me. So for f inverse of x, okay, the domain is equal to the range of the original function. So the domain will be x will be greater than -1, and the range will be y will be greater than 0. And remember, when you sketch these, you would sketch this function, and then you would use the line y equals x, and it would be symmetrical to that line. So you'd see how these domain and ranges make sense. So keep that in mind, okay? So this is what we're going to do. This is the restricted domain, and we're going to get the inverse of that function. Okay, so let's go do our 4 steps as before. So we're over here now. So again, the first thing I do is I write this as y. Y equals x squared plus 2x minus 1. Okay, then I interchange the x and the y. So x equals y squared plus 2x minus 1. I'm sorry, x equals y squared plus 2y minus 1. Okay, we interchange the x and the y. And then we have to solve for y. Now again, we have a quadratic in y, so we can complete the square in y. So what I would do is I'd add 1 to both sides. So this is what I've got. And then I want to complete the square. So half of 2 is 1, so I add 1 to both sides. And now I've got this nice binomial squared. So y plus 1 squared equals x plus 2. Kind of add these over here. Okay, then I take the square root of both sides. So the square root of this would be plus or minus the square root of x plus 2. And this is going to be y plus 1. And then if I subtract 1 from both sides, now we're looking pretty good here. We've got this. Okay, and then we just change that, and we remember the 4th step. We recall that f inverse of x equals -1 plus or minus x, the square root of x plus 2. But remember, since f inverse of x is greater than 0, remember that was my range down here. My range is greater than 0. Since that's greater than 0, this has got to be positive, because if that's negative, remember the square root's always got to be a positive number, so if I take a negative and another negative, I'm going to get a negative. That will not be greater than 0, so I have to use the positive part. That's where the range is going to help you determine what part of your answer you're going to use. So x is greater than -1. Okay. because this has got to be bigger. This here has got to be bigger than 1, because if this is equal to 1, I've got 0, and it's got to be greater than 0. So there you go. So this is how you figure out your domain, just by reversing the range and the domain of the original function, okay? With the restrictions. Hopefully that makes sense.